Next up, mirroring. Mirroring is a concept fundamental to RAID 1 and RAID 10 technologies. And we've got a nice little slide here that walks us through the concept of mirroring and explains how it works. First of all, we've got a write coming in, A, B and C. Now this write stream is directed to a logical volume. Behind the logical volume is a RAID controller. Now this RAID controller, for the purposes of our example, could be either a hardware or a software RAID controller. It really doesn't matter. Now behind the RAID controller are the physical drives that will provide the persistent storage for our incoming stream of write data. Okay, so let's look at the write stream coming in. First up we have our A write coming in and hitting the logical volume. From there it's passed to the RAID controller. Remember, it doesn't matter if this is software or hardware. And the RAID controller then breaks out this A write into two physical write operations, one to each of our physical drives on the back end. This means that if one of our physical drives on the back end fails, we don't lose access to our data because we have an identical mirror copy on the remaining drive. And this mirroring concept is the crux of the fault tolerance provided by mirroring, RAID 1 and RAID 10 technologies. Now let's walk through the rest of our write stream coming in, B and C. So next in line is our B write. That comes in and hits the logical volume. Again, it's passed on to the RAID controller, and as previously, the RAID controller splits this out into two separate writes to each of our physical drives on the back end. So again, our B write is mirror protected. Finally in comes C, hits the logical volume, hits the RAID controller puts it across both drives on the back end, and hey presto, our A, B and C writes are all mirror protected to both of our drives. And bingo, we've got secured copies of our A, B and C write. We're done. Simple. And it really is that simple. Sure, there are different ways of accomplishing the mirroring, especially on storage arrays. It's possible to commit our write stream to one drive and then copy it to the other, or we could make what we sometimes call a duplex write operation, which is a single write operation directed at two physical drives. But how does all of this impact performance and fault tolerance? First up, performance. From a performance perspective, mirroring produces medium to high performance no matter what kind of I/O is involved. So that could be large I/O, small I/O, random, sequential. It doesn't really make that much difference. Mirroring copes with them all pretty well. Now for the effects that mirroring has on usable capacity, well, that's a different story. As we can see in our diagram, we've got 2 terabytes of physical disks sitting at the bottom behind the RAID controller. But we only have 1 terabyte or a single terabyte of usable capacity in our logical volume. So we lose 50% of our physical capacity when we use mirroring, and that's quite a hefty tax. But there are a couple of reasons for that loss. One we've already mentioned, performance. Mirroring doesn't suffer from a performance impact like parity does, and we'll discuss parity shortly. But secondly, mirroring allows us to lose one of those 2 drives on the back end without losing data. In fact, better than not just losing data, it allows us to stay up and running, potentially without taking a performance hit. However, while running with one drive failed, the RAID group is said to be degraded, and by this we mean that the fault tolerance level is degraded. We can no longer lose another drive in the set without losing all of our data. So on that point, RAID systems based on mirroring can quickly recover redundancy, meaning that if we replace the failed drive, the mirror set or the RAID set can be quickly recreated and the logical volume quickly reprotected, or back to full fault tolerance with little performance impact during the reprotect operation. Now if this was new to you, don't worry. You can always hit the rewind button and listen again, or you can wait until we discuss RAID 1 and RAID 10 technologies later in the lesson, where we'll reinforce some of these concepts. Next up though is striping.